Welcome to Study Loop.
Okay, what they're asking you to do is take one of those models of methane and replace one of the balls with chlorine, and then arrange it such that you've got 3 hydrogen balls on the ground, a carbon ball in the middle, and then a chlorine pointing towards you. Okay, and then what they're asking you to do is to take that model, that physical model. Oops. Hey. Okay. Oh, geez. Okay, I just need to start over here. Take that physical model. Those are the hydrogens on the table. This chlorine is sticking up at us. There's carbon in the middle. And then tilt it. Okay, and what they're saying is tilt it this way. Right? And then they're saying tilt it that way. Okay, and if you tilt it the first way, what you're going to end up with is the following. You're going to have a hydrogen coming down to a carbon in the middle, and then a chlorine pointing at you, and then pointing down at the ground to the left and right of you will be hydrogens. Okay, and then the other way they're asking you to do it, I guess they want you to do it. They want you to do it to the left and the right. Okay, well, it's the same either way. It doesn't really matter. I redraw that. Okay, so they have it tilted to the right. So that's what you'll end up with. That's the following. Okay, and if you tilt it to the left, you get this. Okay, now the straight lines are coming up and towards you, and the dotted lines are going into the back. Okay. And then they want you to draw these projections on the report sheet. So what this would look like, if I had to draw it out with a perspective drawing, is typically you draw the bonds that are coming towards you as wedges. Something like that. Not the greatest artist in the world. And the bonds that are going away from you draw as dashes. Okay. You basically do that for both styles. Do that one more time. Oh boy, backwards. Okay. Determine whether the structure of the chloromethane changed while the projection of the molecule will continue rotating the molecule around to determine whether hydrogens are equivalent. Question. Draw two structures. Does the structure look different when you rotate or tilt the models? Are the hydrogen atoms equivalent? Yes or no? The hydrogen atoms are all equivalent, right? This should be fairly obvious, but if it's not, consider that you can rotate 180 degrees to get to that structure, right? There's no really unique way that you can tilt things when you're here, right? Consider that you can just rotate this by 120 degrees and it'll look exactly the same, right? How can you tell this hydrogen apart from this hydrogen if every time you rotate 120 degrees it looks exactly the same, right? You can't. All hydrogens in chloromethane are equivalent. Okay, and I'll give you a hint. If you have a central atom, usually a carbon, you can have up to 4 substituents, right? And unless you have 4 unique substituents, A, B, C, D, unless they're all 4 unique, then any of the ones that aren't unique are going to be chemically equivalent. So if you have A, B, C, C, then these are going to be equivalent, right? And if you have A, B, 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 then all of the B's are equivalent. Anytime you have 3 or 2 of something coming off of carbon, they're going to be equivalent. The only time they're not equivalent is when you have 4 unique things.